Okay, 14 harkens back to Unit 3 as well. They're asking us to find a value of k. K is a constant. Like in other problems, you've seen them say find the value of a or b or c plus d or whatever. I gave you a flashcard. Flashcard says, when they ask you to find a constant, don't. Do something familiar and the constant's value will just appear. You know? Long ago, right? Yeah, I think you're right. You know, one there were problems like that. The limit problem. Yeah. So I'm ignoring k. So if I ignore k, well, all I have is an integral. So my thought is, well, do what we do with integrals. So integrate. Just don't forget the equal sign. Don't forget the equal sign. So tell me what to write here. Hands up. Better that you think than you watch. If you come to class to watch, you should have stayed home. Because you can watch the videos at home. So Bree.
X or X over 2? X over, no.
MCQ.
2 points, but no.
Over 3.
There we go. How many knew it? 2 points, 3 for Bree. It rhymes.
By writing the...
I don't think you get 3 points every time.
Okay. By writing the equal sign over there, you're implying that it all equals 0, right? Okay.
It's perfect. And the implication can get lost. So it's actually smart to do this, Jackie. 2 points. Just don't lose track that it equals 0.
And then do you still leave the equal sign?
You
on
really
the left?
don't. We often put the equal here because we're saying this line is equal to the above, or the above, the above.
Okay.
In this case, with an equal sign on the right, it makes more sense to go like that. Either way is fine. In this case, you can have both because they still are equal.
Okay, because I'll just write both, just so I don't
Yeah,
get it right either.
honestly, the habit I want you to have is every time you draw a line, you got to have an equal sign, and you need to pay attention. Is it truly equal? That's all. Like, what's truly equal? Don't do this. Somebody on the last test, maybe I showed you, they wrote the integral from like 1 to 3 of x squared dx, and they used their calculator because it was a calculator test, and they got something like 1.7. And then they wrote plus the integral from 3 to 5. This isn't exactly what they did, but kind of. G of x. And they picked up their calculator, found this integral, added it to 1.7, and got 3.8.
That's illegal.
Yeah, this doesn't make any sense.
The integral over 1 to 3 of x squared does not equal 3.8.
Yeah, this integral equals 1.7. This equation says this integral equals 3.8, which is false. So that's a really bad use of the equal sign. So, question? Don't do that. So hands up, what do we do next? I'm ignoring K. What do we do next? Adam?
You go to the fundamental theorem, and then you do k over k to the positive minus negative 3 to the positive.
How many knew it? 2 points. Let's pay Adam a ticket for something. He made a comment I want others to notice. I think your thinking was right, your words weren't quite. No big deal. Please raise your hand if you know. Is the fundamental theorem that these two are equal? Is the fundamental theorem that these two are equal? Which? Go ahead. Is it both? It kind of is both, but there's just a little subtle point I want to make. Jacob?
That the first two are equal.
Technically, it's the first two. That this integral is, this integral of the derivative of this thing, like these are equivalent, the two green are the same. That's the fundamental theorem. Really from here to here is just notation, to be honest. The bar simply means to do what we did.
You wouldn't call it
But the first and
simplification.
I don't like the word simplification because I don't think really things are simpler, they're just different. Yeah.
the first and the last are also the fundamental.
You could think of it that way for sure.
Right?
Yep.
So kind of they're both the fundamental.
Yeah, that's why I said it
They're
really
just the
wasn't
same-
wrong.
They're like the same side.
Yeah, it really wasn't wrong to say that. I just kind of want to make the point that the key part of the fundamental theorem is here, but yeah, it's a good comment.
So are you allowed to put k constant as -3? Because then you'd be integrating from -3 to -3.
Oh. Hold on, I pay you another ticket, but I only do one per period. Look up. It's a really good comment. If you integrate from any value to the same value, you are stopping the integral and you're starting and stopping the integral in the same place. So you aren't doing anything. So any integral from 3 to 3 is 0. So at a glance, you are right. If this is -3, this is true. Now, there could be another value of k that also will work, and I don't have the multiple choice answers in front of me. Don't they have multiple?
They have
There's two that
-3,
have
-3,
and
0, 3.
-3.
Right. So we got to make sure there's not another one.
But are you allowed to do -3? Because you're never really like integrating anything.
If you go -3 to -3, you're not integrating anything, and the result is 0 for sure.
So that will be an answer.
I know for certain that k must equal -3. I just don't know if k could equal something else. You with me? Is that your question?
So that means that we can eliminate B and C. Because they don't involve -3.
Mm-hmm.
All right.
No, you're good. To finish the problem, I just keep going. Okay, so that's -27. That's going to be divided by 9 would be, sorry, divided by 3 would be -9 becomes +9. Let's just keep going. A little low on the board there, so we get k cubed over 3 is equal to -9.
So K cubed would be -27.
K cubed is -27. Therefore, k is only -3. Is that one of the answers?
Yeah.
Is that the correct answer?
Yes.
Thank you. Question?
So if it would have been like k squared equals 9, it could be 3 or -3.
Perfect. Did you hear what Jackie said? If the problem had been different, and we'd ended up with like k squared equals 9, then k could be either a +3 or a -3. Please.
Why don't you have the, why isn't it plus or minus 3 on this?
Here.
Yeah.
So you'll get it. Just talk to me. What does it mean to cube something?
Like 3 to the third power,
And what does to the third power mean?
like multiplying it 3 times.
Good. So what's 3 times 3?
9,
What's 9 times 3?
27.
So 3 cubed is a +27. Right?
Mm-hmm.
-3 times -3 is?
9.
Times -3 again is?
-27.
So -3 cubed is -27. So there's only one result.
Oh, because you now have to take a square.
Right. Does that make sense?
Yeah.
Not a square.
No? Please.
On the thing, how did you know to do k to the third minus 3 and not the other way around?
Oh, it's always top minus bottom. That's just a convention. They could have designed the whole process so it was the other way around, and it would have been just as valid, but that's how we do it. Good question.
Will they ever have a smaller value on the top?
Yes. Don't worry about smaller and bigger, just top minus bottom.
That's like when you have the substitution.
It
and
happened.
The top one
Yep.
happens to be-
We saw it in reversed on one of the homework
No way.
problems.
But you still keep it the
Just
same.
top minus bottom. I will show you later a way to switch it, just don't worry about it for now. It's really simple, I just don't want to introduce it at this point. So. Okay, next thing.